and it's a pleasure to be here. I will be your host today for Blockchain Day. And we've got an interesting array of speakers covering a number of different blockchains, and there's a focus on the developer side as well as the enterprise side, which of course is of interest to developers because that's what generates the jobs and the entrepreneurial opportunities. So I'm going to begin today talking about Bitcoin SV, which is a blockchain that you might have heard of. We're not without our controversy, but there's a lot going on in the Bitcoin SV ecosystem. So if we just take a moment whilst I start up the presentation. So Bitcoin SV, massively scaled blockchain to meet developer needs. And those two words, massively scaled, are one of the differentiators, I think, between Bitcoin SV and a lot of other blockchains. I'm going to challenge some of the ideas that are commonly held about blockchain in terms of its scaling capacity. And I hope that that I can convince you that that Bitcoin actually can scale in the way that that was originally described by Satoshi Nakamoto right back in the very beginning. But first, I'd like to take a moment to talk about what is Bitcoin itself. And I'm going to begin with a quote. True history is altered by those who read it to benefit their own aims and to self-affirm their own conceptions. This is a quote by a Japanese philosopher by the name of Tominaga Nakamoto, who lived in the 18th century. And that name might be somewhat familiar to you. There are a few people who theorized that the work of Tominaga Nakamoto was actually in part the inspiration for the Bitcoin white paper. Tominaga was a philosopher, and he was primarily concerned with the accuracy of historical record. In his case, he particularly focused on the canonical texts of various religions, one of them being Buddhism and I believe Confucianism. But he makes this statement here about the alterability of true history, and this is primarily the problem that he tried to solve in his life work. And I believe there's a strong argument to be made that this is a problem that Bitcoin actually solves, because it embraces the concept of public distribution of a record of events in order that any alteration of that record is detectable by anyone across the world. And this has applications that go well beyond preservation of historical texts. It has applications in business. It has significant implications for society as a whole. And so I want to begin with the concept of notarization. If you think about what Bitcoin is, often people think in terms of its payment processing capabilities, its ability to transfer value from one person to another. But when you think about the act of transferring value as it occurs in the world, even before Bitcoin, there's always a lot of records associated with that. And that record keeping was part of what allowed economy to grow and trade to flourish across broader and broader geographical regions. It began thousands of years ago with the Sumerians who came up with the earliest forms of accounting, which is often described as single entry accounting, and that enabled trade in smaller regions. It extended sometime later, I won't try and put a date on it because my history is not that great, into a thing called double entry accounting. And roughly speaking, it's somewhere in the medieval era, possibly a little bit later. That's what enabled global trade to proliferate, because records had some mechanism of authentication. They couldn't be altered easily. And when records were recording things that might be happening on the other side of the world, of course, that's important. Bitcoin kind of takes that concept a step further. And it's this notarization aspect that that is well recognized in the pre-Bitcoin days that Bitcoin allows us to kind of extend. So I'm fond of saying that Bitcoin is, in a more general way of describing Bitcoin, is that it's a global and immutable record of events. Now, payment is just a specific type of event. It's a specific form of the general use case of Bitcoin. And of course, this notarization is something that we've always been able to do. It's happened in the offline world for hundreds of years. We've had these agents that we call public notaries. I'm sure they've had many different names over the last few hundred years. But their job is essentially to act as a trusted authority, to take a document, a record of something, and attest to the truth of that document. And it gets used later on, perhaps in resolution of a dispute, or in normal course of operations. It's simply used to give confidence to the recipient of a document that it is actually genuine. Of course, eventually that function moved online, and we have a number of online notary type services. The people that sign the SSL certificates that power the internet allow us to use secure connections to websites. They're a form of notary. We have things like DocuSign that allow people to sign things online, and it's always important for that signature to be connected to some real world identity in order for it to carry any weight. But we can do better than that. And Bitcoin was the first of the technologies that ever tried to address this issue. Bitcoin has two key features, I suppose, that differentiate it from some of its competitors. One is that it's public, and it's the publicness of a blockchain when it's acting as a notary service for an event, be it a payment or anything else, that effectively makes it unalterable, untamperable. And also there is, of course, the issue of capacity. A service like this is no use to a global economy if it can't actually scale to service that global economy. So why does this capacity matter, and why does the publicity element of it matter? Well, public makes honesty and transparency pretty much a key factor. Once a record is public, it's obvious to anyone if it's ever changed. And we've seen instances in the past where signing authorities, let's call them digital notaries. An example would be one called DigiNotar, and you can see in the name what that's supposed to mean. Had their root keys hacked, but because there was no public record of everything that they had signed in the past, going back 5-10 years, there was no way to authenticate anything that had been signed previous to that hack. Now that's actually not true when you notarize something in Bitcoin. Even if Bitcoin itself was completely compromised, or a signing authority that was making use of Bitcoin was compromised, the historical records still actually have meaning. They can still be trusted because they've been known publicly by a wide array of people who have no interest in hiding a forged record in collusion with each other. Enterprises certainly want this capability, and there's a lot of people that actually want transparency, because when transparency is the default and there are rewards for honest behavior, it makes it easier for people to actually be better to each other when honesty is the simplest path and the path of least resistance. A better and more honest world where people and enterprises can build free from harassment. And it's the publicity that allows us to use a miner's base instincts to make honest security of the network the most sensible choice. And it's simply because any miner that detects a dishonest behavior on behalf of another miner is rewarded for disclosing that. And so we get down to the magic 51% number that's often used with respect to Bitcoin security. It requires a majority of the Bitcoin miners in terms of their hash rate to collude together to be dishonest in order to break the security guarantees of Bitcoin. So I've listed here a few of the common or the more well-known blockchain solutions in terms of their ability to address privacy as well as capacity. Some of these points might be up for debate, and I'm more than happy to have those debates, but this is our assessment, I suppose, that we have made in Bitcoin. And just as a very quick example, we'll get to more of these later, of the use cases for Bitcoin. In fact, we'll hear from one of the people behind Chronoverse a little bit later. It's an esports monetization platform that uses technology for a decentralized and transparent multiverse of competitive gaming. Chronoverse is a fascinating blend of the gaming world and the blockchain world. And Chronoverse actually made a decision to move on to Bitcoin SV for a few simple reasons. Primarily because it's faster and cheaper to conduct trades. As I say, we'll come back to this in a little while, so I won't go into it in a lot of detail. But the fact that Bitcoin SV is capable of handling millions and millions of transactions without slowing down is one of the primary reasons that we hear from applications that want to migrate over to Bitcoin SV. So Bitcoin SV, or Bitcoin, is essentially the fusion of data and money. I'm fond of saying that a Bitcoin transaction is actually a smart data packet. It's a chunk of data which is wrapped up in other functionality like authority, transfer authorization, identity, if you want it, and numerous other things. But down to trying to explain a little bit about what Bitcoin SV actually is. We argue that it's the only version of Bitcoin which actually adheres to the Bitcoin protocol design and vision of the creator, Satoshi Nakamoto, a peer-to-peer electronic cash system and a global enterprise blockchain. Satoshi spoke about both of these things, and the protocol itself is a critical pillar of the Bitcoin SV project. There are 4 pillars upon which Bitcoin SV is built, and as I say, a stable protocol. There's some controversy around this, which I think is rooted in misunderstanding, because since Bitcoin SV acquired the name Bitcoin SV, we've actually had 2 hard forks, one of which was a significant protocol change, the Genesis update, which I'll get to in a minute. But all of those are actually intended to bring the Bitcoin protocol back to the original design that was put forward by Satoshi Nakamoto. And it is absolutely our intention, once that work is complete, which will take 1 more hard fork, which is what we, well, that is the roadmap and the path by which we intend to get there. Then the Bitcoin protocol itself is intended to be locked down forever, which was stated and articulated very clearly by Satoshi. The protocol was set in stone from day one. Scaling, of course, is a significant factor of Bitcoin SV. It was part of the reason why the name Bitcoin SV even came to be. We believe that the model that Satoshi proposed for scaling Bitcoin works, and we've got good reason to believe that it does work. In fact, we have proven that it does work, and we'll get to that in a bit. Security of the blockchain, this refers to the stability of the code, the safety of the code. When you've got code that is underpinning potentially a global economy, that code has got to be robust. If you want banks to use it, there's a whole lot of QA and other layers of assurance that are required. And that is exactly what we intend. We want global financial institutions, we want governments, we want big businesses, we want small businesses. We would like everybody to be able to use Bitcoin as a global plumbing rail, a global payment rail, and a global data rail. And of course, safe instant transactions, which is commonly referred to as zero conf or zero confirmation transactions, is another one of our key pillars. Because we think that if you're in a shop and you want to buy something, you shouldn't have to be waiting 10 minutes for confirmations. The mechanisms for safe instant transactions were built into Bitcoin from day one. And I will explain a little more about that as we go on. So stability and security of the protocol is critical. Stability because big businesses won't build on something that is constantly subject to change. Security, of course, is key. People need to be able to trust the software. This is a picture of just some of the Bitcoin SV team. These are the people that work directly on the node software. In fact, this is a picture that's about a year old now. There's only about half of the current members of the team shown here. At last count, I believe it was somewhere in the range of 50 or 60 full-time engineers who are working on the Bitcoin SV software, as well as associated pieces of infrastructure. We take that security very seriously. We've had the software independently security audited more than once. We've used a company called Trail of Bits, which is probably familiar to a number of people in the Bitcoin SV system. And they've assessed not only the Bitcoin SV software that goes right now, it has its legacy in Bitcoin Core. It is essentially forked from the same code base. So not just the changes that we have made since the Bitcoin SV team was formed, but the actual base software itself, which has its legacy right back to the original code written by Satoshi Nakamoto. So a little bit of quick history about Bitcoin SV. Where did it come from? What is it? BTC is the Bitcoin that most people are probably familiar with when you use the word Bitcoin. It began in 2009 with the first block that was the Genesis block that was created by Satoshi Nakamoto, and then the first block 1, 9 days later, due to some stuff, I suppose, that happened in the interim. And there was a long debate about the Bitcoin block size that culminated in Bitcoin having a hard fork in 2017. And that led to the ticker changing to BCH and the name, which many of you will know, Bitcoin Cash. Bitcoin Cash then continued for another 18 months. But what was very apparent to us was that the idea of bringing the protocol back to the original Satoshi design was not an idea that was shared by everybody in Bitcoin Cash. There were scheduled hard forks every 6 months to make changes to the protocol, and there was no end of argument and disagreement about what those changes should be. There were people that wanted to improve the protocol, or at least believed that they were improving the protocol, and there were people that wanted to bring it back to the original. And that culminated in what's commonly known as the hash war of November 2018, where BCH and BSV went their separate ways. In that particular hard fork, Bitcoin SV restored some of the disabled opcodes in Bitcoin script, and we raised the block size limit again from 32 megabytes up to 128 megabytes. We've subsequently raised it a number of times. But it is interesting to note that since 2018, and since the fact that the proposition of Bitcoin SV was protocol stability, and that there would be no arguments about protocol changes, improvements, etc., other than restoring the well-documented original design, there has been no argument at all in the Bitcoin SV community about protocol changes. There's been no shying away from the hard forks necessary to do the work to bring the protocol back to original design, but it's allowed an unprecedented period of developers simply focusing on building on top of Bitcoin rather than trying to tinker with Bitcoin itself. And a lot of this work culminated on the 4th of February this year with the Genesis hard fork, or we like to call it the Genesis upgrade, which went a long way. We think about 95% of the way toward restoring the Bitcoin protocol to its original design. And that includes some things that were the root of some of the block size wars that happened in BTC between 2014, 2015 perhaps, and then 2017, which culminated in Bitcoin Cash. So we removed many of the artificial limits, not just the block size, but transaction sizes, data capacity, limitations on script. We restored the full functionality of the Bitcoin scripting language. And that goes not to just restoring some of the opcodes that have been disabled, but also removing limits on those scripts, such that many things that were theoretically possible on BCH and BTC are actually now possible on Bitcoin SV. And that means unlocking the real potential of Bitcoin. Satoshi put a scripting language in Bitcoin for a reason. developers that are working on top of Bitcoin for the last 8 or 9 months have finally been able to start exploring that potential. And of course, we removed a couple of the changes that were made to Bitcoin SV, which I'm sure that people at the time felt that they were improvements, but we felt that to keep in line with our proposition of restoring Bitcoin, that it was important to take some of these out because some of them did in fact have unintended consequences. And this is a quote that I mentioned earlier from Satoshi Nakamoto. The nature of Bitcoin is such that once version 0.1 was released, the core design was set in stone for the rest of its lifetime. This is important because Bitcoin is a protocol. It's a very low-level protocol. It's plumbing that most people probably shouldn't see in their day-to-day interactions with it. I would liken it to protocols like TCP/IP and HTTP. These protocols have changed mildly over their lifetimes, but they're largely intact and largely what they were at the beginning. And it's not to say that the protocols themselves were perfect, but people designed around those limitations. And without the basic HTTP that we have today, an entire global industry of the internet never would have been born. I can imagine some of the disruption that would have happened had those protocols been changing constantly. And to give an example, I suppose the transition from IPv4 to IPv6, it's been around. IPv6 has been around almost as long as I can remember, and that transition is slowly happening, incredibly slowly. But in the meantime, the limitations of IPv4 aren't really stopping anybody from getting anything done. And so let's talk about scaling. I'm going to start with an example that Satoshi himself gave, which was Visa, when he talked about how Bitcoin never really hit a scale ceiling. Bitcoin BTC with a 1 meg block limit, which was a limit that was originally put in place by Satoshi. He was convinced by Hal Finney that it was needed early on as a spam mitigation measure. And this was largely because of the fact that at the time Bitcoin had no value, and so there was no disincentive for people to create millions and millions of transactions because the transaction fees were essentially zero. This is not true anymore. If you try to go and create millions of transactions on BTC, Bitcoin Cash, BSV, Ethereum, or any blockchain, you're going to run out of money pretty quickly. But he did clearly give the example of the Visa network, which processes on average about 2,000 transactions a second. We've already got there with Bitcoin SV. We've proven that we can beat and exceed Visa, and we've only really just begun that work. And it's not just us that says that there are scalability problems. Vitalik himself has talked about the Ethereum blockchain being almost full. In a recent article, he talked about how some of that scaling work is going to take years. And I think in part that's because of some of the unique design challenges around Ethereum. But having gone through the Bitcoin protocol in detail, step by step, as we conducted the early feasibility studies of a project called Terranode, I've certainly become convinced that Bitcoin was actually designed to scale from day one. And here it is again. I keep jumping ahead of myself and quoting Satoshi, not realizing there's a slide coming up. Bitcoin can already scale much larger than Visa with existing hardware and for a fraction of the cost. It never really hits the scale ceiling. If you're familiar with this quote, you'll know that it goes on to actually give a much more detailed description of how it can work. But Bitcoin was designed, I've made the claim that Bitcoin was designed from the very beginning to scale. And there are a plethora of reasons that I can give for that, which would turn into quite a long technical conversation. But I'll just give you a couple of examples. The Bitcoin scripting language contains operations called push data, which is how you actually get data into a Bitcoin transaction. And there are 3 versions of this, and one of them is called op push data 4. And it is designed because the one that comes before it, op push data 2, allows you to push a maximum of 65 kilobytes of data into a Bitcoin script. That's already larger than most people think is normal for a Bitcoin transaction. But push data 4 allows you to go beyond the 64 kilobytes and right up to 4 gigabytes. And in fact, there's nothing stopping you from using push data 4 more than once. The simple fact that this opcode exists makes it clear that Satoshi's intent was that, that large data could be used in Bitcoin. And of course, there is the fact that Bitcoin can scale. We regularly see on Bitcoin SV blocks that are far in excess of the sizes that are typical of other blockchains. Earlier this year, in rapid succession, we saw 2 blocks, one 309 meg, one 369 megabytes. On our scaling testnet, we've gone far, far larger than that. But these are blocks that were on the main production network that propagated in reasonable time. I don't believe these particular ones actually caused any orphans, but in Bitcoin SV, we actually are not afraid of orphan blocks. We embrace them as part of the economic model that incentivizes miners to get their act together and be able to handle scale. And of course, I mentioned the scaling testnet. The scaling testnet is a special kind of testnet that is globally distributed, where we constantly test the capacity of not just the Bitcoin SV software itself, but any applications that want to test their own capacity. And one of our milestones, I think, was a day where we managed to mine 2 gigabyte blocks, not just a single one. We managed to mine 20 of those in a row, containing between 2.7 and 6 million transactions. Which gives us a theoretical throughput of about 6,400 transactions per second. This is only 2 years after we started at a theoretical rate of about 22 transactions per second. So you can see the progress, and I don't think I've got the slide here, but I could plot it on a chart for you, and you would see that it is actually exponential progress that we're making in terms of that scalability. So I have every reason to believe that we can continue that trend and go well beyond it. And this brings us to the Terranode project. The Terranode project is a rewrite, I suppose, of the Bitcoin SV client software, the Bitcoin SV node software. We'll reuse a lot of the code that came from original Satoshi code, but it's designed to be horizontally scalable. The problem with the original Satoshi code is that it was a way of bootstrapping the Bitcoin network. It combined a whole lot of functionality for both users of the Bitcoin network as well as the miners of the Bitcoin network. And it does a bunch of things that the miners probably don't need. And it does a bunch of things that the users probably don't need. But it's also monolithic in its architecture. There's only so far you can push it. Because you can't share the load across multiple machines. You can make one machine bigger, but there's only so far that you can go with that. Terranode is designed to break up the functionality of Bitcoin SV and allow it to process and ingest masses and masses of transaction data across a cluster of machines, which means that when you need more capacity, you just have to add more machines. And this is what I was talking about earlier when I said that we had gone through every element of the Bitcoin protocol design step by step as a part of this Terranode project to work out, can we actually parallelize all of this? Is there anything inherent or fundamental to the design that prevents that? And the answer to that question is no, it's not. Bitcoin SV is an opinion that was held, an opinion that is held by every single person that was involved in that workshop. It was about 12 of us, most of them very, very senior architects and many people with years of experience with Bitcoin SV. The unanimous conclusion was that Bitcoin had been designed the way that it had been designed in order to facilitate this parallel processing capability such that it could scale. So let's move on to one of the key features of Bitcoin, which is microtransactions. And this is a consequence of allowing Bitcoin to scale. It's a common thing for many other blockchains that they have scaling limits, they have limits on block sizes. And what happens when blocks start to fill up is you start to create a fee market. And some people think this is a good thing. But we don't think that is a good thing for global adoption, because it becomes a supply and demand problem. There's only so much supply. They can only handle so many transactions per second or per minute or per 10 minutes. But more people want to have their transactions processed than the available supply. And so, of course, they start bidding against each other, and that pushes transaction fees up. And we've seen some extreme cases of it. In Ethereum, we've seen $30 fees. I've seen fees of hundreds of dollars on BTC. It doesn't always happen, but it happens in moments of peak demand. And moments of peak demand, especially if you're talking about payment processing networks, Black Friday sales, for example, are exactly when you need a Bitcoin network to be able to perform. But Bitcoin SV is different because of the fact that we have no cap on the supply of this transaction processing capability. If there are more transactions, the blocks simply get bigger, and that might cause issues for the miners. They might have problems propagating their blocks fast enough and end up in block races. But from the user's point of view, none of this matters. Because if your transaction gets confirmed in one block and that block gets orphaned, well, there's a good chance it's going to end up getting confirmed in the other block as well. If a double spend happens, it's fundamentally no different to a double spend happening in a small block environment. But there are other mechanisms to handle, detect, and propagate the existence of double spend in Bitcoin SV. And the end result of this is that there is a fee market in Bitcoin, but it's not users competing for the highest price to push the price. It's not users competing, which results in the price being pushed upwards and upwards. It's actually miners competing to push the price lower and lower by getting their own costs lower, by getting their capacity lower, which enables more and more volume. And right now, the cost of Bitcoin and transactions, if you're used to the cost of transactions on many blockchains, this might come as a surprise to you, but it's less than 1/100th of a US cent. It varies a bit between 1/100th and 1/10th, but it's almost always below 1/10th. And Bitcoin SV miners are starting to implement really interesting capabilities like floating fees that enable them to keep those fees stable in US dollar terms, so that businesses who actually need some certainty about the price of getting transactions processed, they have that certainty. They don't have to worry if they're sending out 1 million transactions a day that suddenly the price of doing that is going to double because the Bitcoin SV price doubled. And conversely, when it drops, the miners don't need to worry so much about suddenly having a massive drop in revenue. So, as I say, this average fee tends to float around, but the simple economics of the fact that there is no cap on supply means that there is no economic reason why these transaction fee prices are ever going to reach some of the astronomical levels that we commonly see in the blockchain world. So this allows us to do a whole bunch of things, things like reinventing the internet with a new world of micropayments. And here are a couple of the things that suddenly become feasible. Tiny payments, a few cents, even fractions of a cent. So if you could pay to post on social media and create content, that gives the readers some level of assurance that you're not just spamming and producing rubbish, but that also allows the readers to pay you for your content. Pay to store your identity and data on chain, pay to store it on chain so that you can own it, pay to read articles. We've seen this business model working really well on various platforms with low fee blockchains, and it turns out people are actually happy to pay for content. Pay to watch by the minute for video content, and of course in-game and virtual items. We're all used to, well, some of us are used to watching an ad to get some little goodie or widget in a mobile game, or paying to get in-game tokens. But usually with those tokens, you've got to pay, a minimum of $1 or a couple of dollars. Imagine being able to pay for those in fractions of a cent. And of course, it creates many opportunities for the end users of Bitcoin to get paid themselves. Imagine if you were getting paid to watch an ad rather than Facebook getting paid. Imagine getting paid to selectively give access to your information. It could be any information. It could be info about your spending habits. It could be anonymized medical information. If you want to make that available to somebody who wants to mine that information, you can, but it becomes your choice. Get paid to give your location, even get paid to read emails. There's a lot of people out there who want your attention. And right now, Google and Facebook are monetizing that fact because they believe that your attention is worth something, but they don't want you to know that. But when you're able to transact in micropayments, it all becomes suddenly very feasible. So Bitcoin is about a world that is online and on chain. And we like to talk about a thing called MetaNet, which is a new, more commercial internet for users. The MetaNet paradigm is about the blockchain acting as a universal server. And that doesn't mean all data necessarily gets stored on the blockchain, but it can. Data for websites, content, they can be hosted on chain, their hashes can be hosted on chain, and the data can be accessed from elsewhere. But it provides a single source of truth and a mechanism to structure data that can be universal. And here are a few of the applications that we've seen people using MetaNet data structures, which leverage the concept of a Bitcoin transaction being a smart data packet to add structure that meshes with some of the guarantees and ordering guarantees that Bitcoin as a platform gives you, but also builds additional layers on top. So for any of the developers in the audience, I'd like to give you a bit of an idea of what you can build on Bitcoin SV as a developer or even as an enterprise. Here's an example who's a winner of one of our recent hackathons, a project called Coda. I know the name is a bit of a mouthful, but it's pronounced Coda. It allows you as a developer to monetize your API, which means you can choose to get paid for every single call to an API in tiny increments. And in fact, we even have a thing now called nano payments, which is a mechanism to allow you to receive payments that are actually even lower than a transaction fee, and by piggybacking off another transaction. And Coda is a perfect candidate for the use of these nano payments because they can batch a whole bunch of them together. But when I first saw the presentation on Coda, they gave an example of an open source tool. I can't recall the name of it, but it was a Node.js library that was available via NPM. And the example was something along the lines of if that person had received 0.1 cent for every download, they would have made in the region of 800,000, or it might have been $8 million. I know I've got a off by one order of magnitude error there, but that was roughly the number. Buscon is a Korean project that brings the capability for musicians to monetize their content on chain, either by putting the content itself on chain or leveraging the chain to allow people to literally pay per second of view. And just to give you an idea of some of the activity that's going on in Bitcoin SV, this is a bit of an ecosystem chart. These are a bunch of projects that have been built on SV over the last 2 years since we took the name Bitcoin SV. This is just the first of a few pages. Some of them have succeeded, some of them probably aren't here anymore, but it gives you an idea of the sheer rate that new projects are coming in. So these are some resources. And these are protocol layers. These are platforms that you can actually build on top of. And there's more and more of them appearing every day. Handcash Connect is an API, a payments API that basically makes the whole payments thing easy for you. It does, it allows for instant payments. It has mechanisms for end-to-end encryption. It handles blockchain data, makes it easy for you to get blockchain data on and off the blockchain, identity and login, and many other things. Maxthon is another really interesting project. It's a browser project, which I have to be honest, I hadn't heard of it before it appeared on Bitcoin SV, and started adding support for it. But it has 670 million users, primarily in the in China, but I believe that they are starting to spread far and wide, and they've won numerous awards as one of the competing blockchains that's not quite in the big four, but here you can see up there top left they are actually in the big five. And so Jeff Chen, the founder, is very clear that that he wants to make his browser seamlessly integrate with Bitcoin SV applications, so that you don't even need to know whether BSV is involved in the background. So I'm going to jump back again to scaling, because the scale element of Bitcoin is actually so important to what Bitcoin is. It's part of what enables Bitcoin to be secure, and it's part of what enables many of the features of Bitcoin to actually become unlocked. I'm really fond of saying that that Bitcoin never got a chance to be Bitcoin, because before rules and restrictions started to come in to limit the ways that people could use it, Bitcoin was actually tiny, and it doesn't really start to exhibit some of its real properties until it hits scale. And of course, by the time Bitcoin had a lot of users involved in it, making use of it rather, by that time, there were so many limits imposed upon Bitcoin that could constrain how you could use it, that some of those properties were never able to be exercised. So firstly, we want to talk about big blocks, big transactions, and big scripts. But firstly, I want to talk about the configuration of the Bitcoin network, because I think one of the common myths about Bitcoin is how it's supposed to operate. And the idea that everybody should run Bitcoin nodes, unfortunately, leads to a network configuration that is suboptimal, and it's not actually what Satoshi described. It leads to a mesh network, and this is the way that people mostly use Bitcoin today. You have a customer and you have a shop, and someone wants to make a payment from one to the other. The customer sends a transaction and it bounces around various nodes in this mesh network until eventually it propagates out and the shop receives it. And that has two really interesting consequences. One, it takes a long time, actually more than two. Two, the customer has no way of knowing how long it's going to take for the shop to receive it. Three, the shop has to listen to everything in order to find that transaction. And the last point that I'd like to make is that this is actually a kind of a crazy way to do it, because the customer and the shop are already talking to each other. They had to talk to each other to negotiate the terms of the transaction. So why not pass them to each other directly? But when you have big blocks, it creates an incentive for miners to get themselves well connected to each other. Because if they're not well connected, when they mine a block, there's a real risk that their block will get orphaned. And this doesn't punish the users, but it punishes the miner, because they lose the block reward. They lose all of the transaction fees that might be a part of that block. And so the first time this happens to a miner, and we've seen it on Bitcoin SV when new miners have come in not realizing how this actually works, the miner suffers a loss. And they don't want to suffer a loss anymore, and they understand that the way to avoid suffering a loss is to start to do this. The yellow ones are the miners. The miners start connecting directly to each other, because the more well connected they are to each other, the faster they can propagate their blocks to each other, and the less of a chance of them getting their blocks orphaned. And that's a Bitcoin using economic incentives in order to push the miners to increase their capacity and enable scale. Another thing happens is that miners start getting a little bit picky about who they connect to. If they've got thousands of users connected to them who are receiving all of this data, or sorry, who the miners have to send all of this data for every single block, most of that data that those users actually don't need, then that's consuming their resources. These are resources that don't offer any benefit to the miner, whereas resources put into the connection between the miners are the ones that actually create the reward for miners, or rather, they prevent or they minimize the risk of miners losing reward through incentives. And the customers, as I say, don't actually need all of this data. This is part of the SPV model that Satoshi describes in section 8 of the Bitcoin white paper. And so now we move to a model where this can happen. And you'll note in that very first diagram, we saw that network propagating, that transaction, propagating through the network, and it took 4 or 5 steps before it got to where it needed to go. We didn't show it propagating to the other miners because we didn't have the miners identified there. But the faster that transaction gets to all of the other miners, the quicker you have zero conf or zero or safe instant transaction assurance, because miners actually respect a thing called the first seen rule, which means they will accept the first version of a transaction that they see. That's not necessarily true with BTC because they introduced a feature called replace by fee, but there's no need for a replace by fee in Bitcoin SV because you can gain complete predictability of the fees that are required to get your transaction accepted. And so this is what a typical interaction now looks like. Transaction goes directly from the customer to the shop. The shop doesn't need to listen to the rest of the Bitcoin network. They just need to maintain a connection to a miner or maybe a couple of miners, but they don't need the miner to send them all of the information. They get the transaction direct from the customer, and it's the shop that actually cares about getting the transaction confirmed. So they can establish now a direct connection to the miner, and we have tools in Bitcoin SV that enable the merchants to actually find miners and connect directly to them. They can send it to the miner, and bang, the miner sends it to every other miner in a single hop. So you should be able to get an answer to the question, is this transaction going to be confirmed, or is it a double spend, within a fraction of a second? That's possible on Bitcoin SV. Along with being able to connect to the miners and get that answer from them directly, we also have a feature that enables you, the merchant, to be notified in the instant if there is a double spend. And so knowing that there's a double spend on a network is pretty much as good as preventing it itself, as long as you know quickly, because chances are the customer is still going to be in the store. The analogy would be if you were sitting in a store or standing in a store trying to buy a bottle of water or a can of Coke, and instead of handing over a £5 note, you hand over a Post-it note with £5 written on it. If you try to do that, the merchant's going to know immediately that you're trying to pay them with a very poor counterfeit note, and they're not going to proceed with the transaction. Of course, in a Bitcoin situation, knowing that a transaction is a double spend is a precise analogy of that. So let's talk about the peers now for a moment. This is the very first sentence of the white paper, and this is why I make the argument that Bitcoin intended users to be users, that Satoshi intended for Bitcoin users to be users and for miners to be miners, or rather nodes to be nodes. The word peer often gets confused as if there's only one type of peer on the Bitcoin network, but the definition of a peer is a group of parties that share some sort of commonality of status or capability or something along those lines. So there's more than one set of peers in the Bitcoin network. And here, a purely peer-to-peer version of electronic cash, it's very clear that Bitcoin is supposed to be electronic cash, and also that it's supposed to be peer-to-peer. But here Satoshi describes the first type of peer, would allow online payments to be sent directly from one party to another. This is users, and this describes exactly what was in the diagram before, where we had customer and shop, and customer sending the transaction directly without going through a financial institution. The analogy in the Bitcoin network, of course, of a financial institution is the miners, not just one. It's more than one, and that's a very important concept in Bitcoin. But two peers don't need to go through a financial institution in order to exchange a transaction. They use the financial institution for the settlement and clearance part of the transaction, but not for the actual exchange itself. And Satoshi attempted to show this as a proof of concept in the very first version of Bitcoin with a thing called IP to IP transactions, which enabled precisely this functionality. It was a very early prototype and it was missing a few things and it was subsequently removed. But I think the fact that it was there shows the intent. Now on Bitcoin SV, that workflow that I showed you is actually enabled not just by the Bitcoin node software itself, Bitcoin D as it's commonly known, but by many other products that we've put together that make all of this simple. There's the MAPI or Miner API, which enables Bitcoin users to connect directly to miners to submit transactions. There's Paymail, which is an identity mechanism that allows you to find services attached to another user. BIP270, which is an extension of BIP70, or rather a simplification of BIP70, which defines how users and customers and shops, the merchants talk to each other. Miner ID, which allows miners to advertise their identity and their services with a provable pseudonymous identity. It's kind of like the messages they leave in Coinbase transactions, but with actual cryptographic proof backed by their proof of work. And SPV Channels is a very non-Bitcoin-y communications mechanism that facilitates a lot of this. So you can find out a lot more about this on the Bitcoin SV website. It's bitcoinsv.io. And it's not just a home for the Bitcoin node software, but also a home for a lot of these supporting pieces of infrastructure, which are the elements that you most likely need to interact with as a developer. So I'm running a little short on time. I was worried I wouldn't be able to stretch for an hour, but I shouldn't have worried too much. So this is kind of going a little bit back over some of the old ground, but just some examples of what we've actually been able to achieve in terms of block sizes on Bitcoin SV. This is a logarithmic chart, of course, so the peaks go a lot higher. Why big blocks matter. Fundamentally, it's because Bitcoin miners need revenue in order to sustain the infrastructure of the service. And as we know, the block reward is dropping year by year. And the only way to replace that in Bitcoin is with transactions in massive volume. You can't do that by increasing the transaction fee, because that will just drive away users and it limits the pool of available users of Bitcoin severely. So it puts an upper limit on the cap, an upper cap on what is possible in terms of Bitcoin scaling. Big transactions, of course, they're important to enable a bunch of use cases that I'm sure many people think shouldn't be happening on Bitcoin. Things like Bitstagram, which I'm sure you can imagine what that is. It's a Bitcoin-style version of Instagram. Weather SV, which records for provenance data of many other data points of weather over history in a way that's provably unchangeable, so that in future decades or even centuries, scientists will be able to mine that data knowing that it hasn't been changed. Memento is another social media platform. And of course, there's Crypto Fights, which combines online gaming with the immutability of Bitcoin. One really interesting use case that I want to show you is something from a company called EHR Data, who are primarily concerned with healthcare records in the United States, and they're particularly attacking the opioid crisis. And without going into too much detail of the system, they envisage making use of about 3.2 million transactions per day initially, eventually rising into the billions. But this is just for opioid prescriptions. And in order to get all of the historical data onto the blockchain, just showing a few quick metrics in terms of how long it would take to do that. So with the current block cap on Bitcoin BTC, it would take about 44 days to get that data in. With Bitcoin SV right now, given the current capacity, you could drop that down to 32 minutes. And of course, once we get to Bitcoin Terranode, that is going to increase dramatically. And the last thing I want to touch on is Bitcoin scripts, because this is really the capability of Bitcoin that has been lost to us for so long. This is a long Bitcoin script, and here's something that it's not necessarily the same code, but it's an example of Ethereum Solidity. But this is what people tend to think of with Bitcoin script. It looks very much like assembly language. It's utterly horrible to read, to look at, and trust me, it's even worse to try and code in it directly, especially with the tools that are available. But that is changing on Bitcoin SV. Over here on the right-hand side, we have a language called script, which looks very much like JavaScript. And this actually will compile down into a Bitcoin script, which you could liken to the bytecode, much like what sits behind Solidity. So script is available as a Visual Studio VS Code extension, as well as in its native form. And here is an example of some of the functionality that you can do with Bitcoin scripts. This is very similar to an opcode that other blockchains have introduced called DataSig Verify, or check DataSig. It basically allows you to put data into a Bitcoin script and have an Oracle sign it and verify that signature to prove that it actually came from the Oracle. And it's not the only one. There's many smart contract languages that are happening in Bitcoin SV. So I've run out of time here, so I'm going to bring this to a close. I think possibly